this is Jo from Math Tutor Me. Today we are doing surds and we're going to rationalise the denominator. What that means is that we're going to be rearranging the question so that the denominator is a whole number, not a surd. So here is an example. We have a square root 2 on the bottom. That is irrational, so that is the thing that we need to get rid of. So to express this with a rational denominator, I need to get rid of that square root of 2. So the easiest thing to do that is to multiply your problem by whatever surd you have on the bottom. So I have a root 2 on the bottom, so I'm going to multiply by root 2. Now I can't just multiply by something and change the value. What I need to do is multiply by root 2 over root 2. So really those two things could cancel off and I would just be multiplying by 1. So I'm not really changing the value of my number here, but I'm just rearranging it so that I can get rid of the surd on the bottom. So then I can multiply. To multiply fractions, we multiply across the top. Root 7 times root 2 equals square root of 7 times 2 is 14. And then we multiply the bottom. 2 root 2 times root 2. 2 is out the front, and root 2 times root 2 just becomes 2. The square root disappears. And now I have a rational denominator. So simplifying, square root of 14, that can't simplify at all, over 2 times 2, which is 4, and that's my answer. Let's do that again. So to rationalise this denominator here, the square root of 3 is my surd, so I need to multiply by square root of 3 over square root of 3. Okay, then I multiply everything out. So multiplying the tops together, square root of 75 times square root of 3 makes the square root of 225 over, multiplying the bottom together, the 5 is out the front, and root 3 times root 3 makes 3. Okay, collect the bottom up, square root of 225 over 15. But can I simplify that square root of 225? Well, if you type that into your calculator, it is actually a perfect square itself. So the square root of 225 is 15. So I have 15 over 15, which gives me 1. Alright, that is my answer. So this is the very beginning part of rationalising the denominator. There is some harder questions to come, but we'll start with these today. So let's have a practice. So for you to do these questions, your steps are to multiply by the surd on the denominator over itself and then completely simplify. So grab your pen and paper, turn the video off and have a try of these two questions. Alright, how did you go? Let's go through the answers. So my surd on the bottom is a square root of 6, so I have to multiply by square root 6 over square root 6. Then multiply together. 4 times square root 6 is 4 square root 6, and root 6 times root 6, square roots cancel, and I just get 6. I can cancel here. The 4 and the 2 can both be divided by 2, which would give me a 2 root 6 over 3 for the best answer. Alright, let's try again question 2. To rationalise the denominator, I need to multiply by that surd on the bottom, square root 35 times square root 35. Multiplying together, multiply the tops. 3 root 7 times root 35 would be 3. Root 7 times root 35 is square root of 245 over root 35 times root 35 is 35. Now 245, that's a pretty big number. Can I simplify that? So we have a look at our perfect squares. 245 can be divided by 49, and it goes 5 times. So leave the 3 at the front. 245 is 49 times by 5. I still have over 35. Then I can split my surd. So 3 square root 49 times square root 5 over 35. The square root of 49 is 7. 7 times 3 is 21, square root 5 over 35. And 21 and 35 can both be divided by 7, giving me 3 root 5, move this up a little bit, over 35 divided by 7, which is 5. Squishing it in there at the bottom. Hope you can see that. So that's your answer, 3 root 5 over 5 with a nice rational denominator. Okay, so tune into my next video on how to rationalise denominators of slightly harder kind. Until then, keep practicing and we'll see you then.